Question number 30. A variable plane is at a constant distance 3p from the origin and meets the axis in A, B and C. Prove that the locus of the centroid of the triangle ABC is x raised to minus 2 plus y raised to minus 2 plus z raised to minus 2 equal to p raised to minus 2. Now we know that if it's let's say A is A0 and B is 0, 0, C. Let's assume that these are the points A, B, C which are in the axis. Now any plane that pass through A, B, C is given by the equation x by A plus y by B plus z by C equal to. If you are not familiar with this equation, you can easily derive this equation from starting from the standard formula Lx plus My plus Nz is equal. Now substitute these 3 points to this equation and eliminate L, M, N and P. So you will get this equation. I have discussed the derivation of this equation in few questions before. You can check that also. But I think I discussed that in 7. Let me just check. This is the derivation of that equation. You can pause and see. This is the derivation. So anyway, back to our question. If you are not familiar, do remember this equation. This equation comes handy in lot of questions. So let's call this equation 1, and it is given it is at a constant distance 3p from the origin. So distance of plane 1 from origin 0, 0 given by this equation. It is by 1 by root of so let's call this p. Let this be p. That means if you invert and square it, we have 1 by p square. So it is given as 3p, not p. It is given as 3p, right? The distance is given as 3p. As 3p. So inverse and square, we have 1 by 9p square is equal to 1 by a square plus 1 by b square plus 1 by c. So how did we get this part? This part, you have ax plus by plus cz plus d equal 0 as a plane, and if you have a point x1, y1, z1, distance between this point and plane is given by ax1 dz1 plus d by of a square plus b plus c. I have used this equation to find the distance between origin and the plane. So you will get, if you apply this equation, you get this as our distance. So since our d is minus 1, doesn't change. Like if you invert and square, this minus sign goes. So anyway, this is we get this equation, and let's call this 2. Now prove that the locus of the centroid of the triangle ABC. What is the centroid of triangle ABC? Centroid of ABC given by we know that ABC are these points. So centroid is given by A plus 0 plus 0 by 3. So A plus 0 plus 0 by 3, B 0 plus B plus 0 by 3, 0 plus 0 plus C by 3. The equation of centroid. So you have 3 vertices and you have x1, y1, z1. x2, y2, z2, x3, y3, z3. Centroid of this point is given by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. That is what we have written, which is nothing but a by 3, b by 3, b by 3, c by 3. This is the centroid. Now we just we have our locus point Q. Say the centroid B, centroid, let's call centroid as our Q, and Q is that means our x is the locus point to find x is equal to a by 3, or a is equal to 3x, y equal to b by 3, or b equal to z is equal to b by 3, e equal to bz. Now xy, our center, let the locus point be x, y, z. To find x, y, z, which is the locus of Q, which is the point Q. Now we just have to eliminate this a, b, c using 2 and this. One by 9 p square equal to by a square. A square 1 by 9 x square. 1 by 9 x square by 9 y square. So cutting 9 throughout, we get 1 by b square is equal to by y square. So this is the required equation of the locus of point Q, or in the centroid of the triangle ABC. The steps: get 1 by x square plus 1 by x square plus 1 is 1 by our locus of locus equation. So solution to question 30.